So in this question, we're given a diagram. So in this diagram, D is the midpoint. D is the midpoint of AB. F is the midpoint of AC. And then E is the midpoint of DF. And AB is parallel to CF. So we can see that from here, D is the midpoint of AB, and then E is the midpoint of AC in this triangle, in triangle ABC. And then we can also see that E is the midpoint of E. This E here is also the midpoint of DF. And also we are given that AB is parallel to CF. So now, let's look at this first question. The first question says that we have to prove that ADE is congruent to triangle CFE, right? So proving this, we'll look at triangle ADE, and this is triangle. Let me just highlight triangle ADE. So this is triangle ADE. And then CFE. This is triangle CFE. All right. So now, let's take a look at these two triangles, and then let's prove that ADE is congruent to triangle CFE. So now, first things first, what I can see here, I can see that this line is equals to this line. Hence, that's given. So I can eventually just say AE is equals to EC. Reason being given from the statement, it's given. And then we are also given that DF is equals to what? EF. I mean DE is equals to EF. Right? So this implies that DE will be equals to EF. This is also given from the statement that's given. And then lastly, we can see that from here, this angle and this angle will be equal since these are vertically opposite angles. So I can say D angle EA will be equals to C angle EF. Reason being vertically opposite angles that are equal to each other. So now from this, we can then now conclude that therefore triangle ADE will be congruent to triangle CFE. Reason being side, and angle. So this is a side, right? This is a side, this is a side, and this is an angle. So it will be side, angle, side. So our reason here will be side, angle, side. So now let's look at the next question. So the next question, we are supposed to prove that DBCF is a parallelogram. So how would you prove that something is a parallelogram? So now, I would like us to consider something here, right? I would like us to consider something. So we'll consider so let's highlight what we are required to prove first. So we're supposed to prove that DBCF is a parallelogram. So let's highlight that. Right? So by looking at this, proving this, we are going to use congruency. So we are going to consider this triangle here. We're going to consider this triangle here. And also going to consider this triangle here. I'm going to prove this here. I'm going to start with the one in red. I'm going to say, first things first, I'm going to say consider the two triangles, triangle are BCD and triangle DCDF. We're just going to consider these two triangles. So we're going to start with this triangle, the red one. So first things first, we are going to look at from between these two triangles, we can see that these two triangles have a common side CD. CD is a common side. So CD is equals to CD, present being common side, which is equal in both triangles. And then we also know that since you already proved that this triangle here is congruent to this triangle here, this triangle here is congruent to this triangle, this implies that this side will be equals to this side, right? From congruency, if this one is equals to this one, this implies that this one will be equals to this one. So I will say, since AD is equals to FC, I don't know whether this is FC, this has to be C and this has to be F, so is equals to CF from congruent triangles, which we proved already that this triangle and this one are congruent to each other. And we also know that AD is equals to, DP, which is given, right? And then we can see that both CF and DP are equals to the same thing, right? So this implies that, so we'll say therefore CF is equals to DP, since they are both equals to AD, right? So we have the first point and the second point, right? So if this one is equals to this one and this one equals to that one, this implies that this one is equals to, will eventually be equals to that one. That's what I was trying to say here, right? So, but let's look at the last point. So the last point, you are going to focus on this parallel lines. Remember, this is parallel to this, right? AB is parallel to CF, right? So now, when you see parallel lines, we have to consider phi, right? Let's see, F is not here, but what I can see a Z being formed here. I can see a Z being formed. So now, if I can draw a Z like this, going like this, and then come, I can see that this angle here will eventually be equals to this one. So I can see that B angle DC will be equals to F angle CD. Alternate angles equal, since we have AB parallel to CF, right? Since we have AB parallel to CF. So now, since we have 3 points, the first point, the second point, and the third point, therefore we can now conclude that these two triangles, triangle BCD will be congruent to triangle CDF. Reason being, we have an angle, so this is an angle, this is a side, and this is a side. So we have side, angle, side. So now, since we already proved that these two triangles are congruent, this implies that they are equal in all respect, right? Hence, they are equal in all respect. This implies that DF will eventually be equals to BC from these two triangles. Reason being, from congruency, congruent triangles are equal in all respect, right? This makes this side here equals to this side, right? So now, if this side is equals to this side and this side is equals to that side. This implies that this will eventually be a parallelogram. So therefore, DBCF is a parallelogram. Why? Why is this a parallelogram? Because in a parallelogram we know that opposites sides of a parallelogram. Okay, now a pair of opposite of a parallelogram are equal. So now let's look at this question. So C says, hence prove the theorem that states that DE will be equals to 1 over 2 BC. Right? So that's the midpoint theorem. So I'm just going to highlight the triangle that they're talking about. So in this question, we're supposed to prove the theorem that states that DE is half of BC. So let's go to our sketch and look for DE. So we can see that DE is a distance from here to here, right? And then BC, it's a distance. So BC is a distance from here to here. Right? So they're saying DC is half of BC, meaning BC is twice DE. So now, in this question, I would like us to focus on this triangle here. On triangle ABC. Right? I would like us to focus on this triangle here. So, from the initial statement, we're given that D is the midpoint of AD. So D here is the midpoint of AB, is the midpoint of A and B, is the midpoint of this line, meaning this D divides the two sides equally, right? Making AD equals to DB. Also given that F here is the midpoint of AC. F is the midpoint of AC, right? So this eventually tells us that if F is the midpoint of AC, this makes AF equals to FC. DF is parallel to DC. Present being that DBCF is a parallelogram, right? So DF will be parallel to BC. DF will be parallel to DC, present being opposite sides of a palm are parallel. And then from this, we can eventually conclude from here that DE, so you can say therefore DE will be equals to 1 over 2 BC. Reason being, this is the midpoint theorem. So this is basically how you prove the midpoint theorem.